Vaccines have an excellent safety record. Like any medication, vaccines can sometimes have side effects, but those are typically mild. Nevertheless, unlike any other form of medical intervention, vaccination continues to stir up emotions. Because vaccination is a preventive measure that is protecting you from something that might happen in the future, it's very easy to overestimate risks, which are tremendously small, and underestimate the actual benefits, which are very high. In addition, because vaccines are so effective in protecting us against diseases, some of these diseases have become extremely rare compared to the pre-vaccination era. That creates a false sense of safety, where people feel they don't need to get vaccinated because the disease is so rare anyways, which of course is a fallacy. The disease is rare because people get vaccinated, and if people stopped getting vaccinated, the disease would become much more prevalent again. Let's take a look at a famous example of the consequences of a vaccine scare. In 1998, a medical journal called The Lancet published a study that linked the combined vaccine against measles, mumps, and rubella, the so-called MMR vaccine, to autism. The study turned out to be fraudulent and has in the meanwhile been retracted in full. And multiple studies since then have concluded that there's absolutely no evidence for such a link. But the fraudulent study caused a vaccine scare, and it contributed to a severe drop in MMR vaccination rates in many countries, most famously perhaps in the UK. Those drops in vaccination rates led to reduced herd immunity, which in turn led to increased numbers of measles cases. But there is also another factor that can lead to an increase in disease incidence, even when vaccination rates remain constant over time. This factor is the increased clustering of unvaccinated individuals. For example, parents who choose not to vaccinate their children may preferentially send their children to schools that are supportive of such decisions. Also, people who have strong negative views on vaccination may start to influence and scare others, which could lead to a drop in vaccination rates in certain communities. Such clusters of unvaccinated people put those communities at high risk of local disease outbreaks. That's bad news for everyone, but it's very bad news for those who can't get vaccinated for medical reasons, because they are too young, allergic to components of the vaccine, or because they are immunocompromised. The key message here is that just looking at vaccination coverages alone is not going to tell you everything about the probabilities of outbreaks. Let's use a social network analogy to make the point. Consider this simplified social network. The nodes here are people, and the edges are contacts between people where a disease can be transmitted. Let's say you have a vaccination coverage of 80%. I've colored 80% of the nodes here in blue. These are vaccinated individuals, and the rest is susceptible. What I'm going to highlight now is the longest possible chain of transmission between unvaccinated individuals, the worst case outbreak size. And as you can see, it's only 15 individuals. Now let me redistribute the vaccination statuses. This is the same network as before with the same vaccination coverage, 80%. But as you can see, there is now a cluster here of susceptible individuals. Now I'm going to highlight the longest possible chain of transmission in this network. Here it is. And now look at the numbers. The worst case outbreak size is now 90 individuals, which is 6 times higher than in the example before. Again, this is the same network with the same vaccination coverage, but drastically different worst case scenarios because of the clustering of individuals that are not vaccinated. What I've just described is likely what has been happening in the past few years in European measles outbreaks. Between May 2011 and April 2012, Europe has seen 17,448 measles cases. Of those cases where the vaccination status was known, only 4% were sufficiently vaccinated, which is a vaccination rate that is much, much lower than the average vaccination rate. So to sum up, if you want to protect the population from vaccine-preventable diseases, by all means try to get the vaccination rates up as high as possible. But at the same time, also try to avoid large clusters of unvaccinated individuals, because such clusters can lead to large disease outbreaks even when you have high average vaccination rates.